This is the demo for College Algebra Lesson 22. Now that we've explored the concepts of end behavior, zeros, and their multiplicities for polynomial functions, we are ready to learn how to create a quick sketch of a polynomial function. So for example, we're going to look at f of x equals x to the fifth minus 6x to the fourth plus 9x cubed. We start by determining the end behavior. Remember, we look at the degree, which in this case is odd, and the leading coefficient, which in this case is positive. So odd means one arm up, one arm down. Positive leading coefficient means right arm up. So that's my end behavior. Right arm up, left arm down. So as x goes to infinity, as x goes to negative infinity, the y values also go to negative infinity, they go down. And as we go to the right, to positive infinity, the y values go up to positive infinity. So I want to find the x-intercepts of this function by setting it equal to 0. We have a little practice here, a little opportunity to go back and remember how to solve these kinds of things. I'm going to factor out the greatest common factor here. Every single term has at least an x cubed in it. So I'm going to do 0 equals x cubed, factoring it out. And then I'm going to determine what has to go in this parentheses so that when I distribute the x cubed to each term in the parentheses, I would get this. So x cubed times what gives me x to the fifth? X squared. And then x cubed times what gives me negative 6x to the fourth? Negative 6x. And then x cubed times what gives me 9x cubed? 9. Okay, and then x squared minus 6x plus 9 can factor further. So I have 0 equals x cubed times x minus 3 squared. X minus 3 times x minus 3. So one real 0 of the function is 0, right? I'm going to set each factor equal to 0 separately. So x cubed equals 0, or x minus 3 squared equals 0. And my zeros are 0 and 3. Okay, so my 0 that is 0 has odd multiplicity because it was an x cubed equals 0. So x times x times x equals 0. X equals 0 ends up being a 0 3 times. Odd multiplicity. And that means it's going to cross the x-axis rather than bounce off. And then my other 0 is x equals 3. It has even multiplicity because of this squared here. X minus 3 times x minus 3 equals 0. X equals 3 becomes a 0 2 times. Even multiplicity. And that means it bounces off the x-axis at that point. So to find the y-intercept, remember you make x 0. When you make all the x's 0, the y comes out to be 0 in this case. And then we want to check for symmetry. Does f of negative x equal f of x? Well, let's see. F of negative x. That would be negative x to the fifth minus 6 times negative x to the fourth plus 9 times negative x cubed. And that gives me negative x to the fifth minus 6x to the fourth minus 9x cubed. Okay, this is not exactly my original function, so it does not match exactly the original, nor is it exactly opposite the original. So I have a negative x to the fifth, so I changed the first sign from positive to negative, but the second sign was negative and it's still negative. So this is not exactly the opposite. I have not changed every single sign, which means it is neither even nor odd. The maximum number of extrema would be 1 less than the degree, which is 4. And then let's see what I can do to graph this thing. So my zeros are at 0 and 3. And I know that my end behavior is rises to the right, so I'm going to put something like that. And then it falls to the left, so it has to be something like that. And then in between, I know that when it hits this x-intercept at 3, it's supposed to bounce off. So this has to bounce off and come back down like that. Kind of smooth that out. And there's a rough sketch of my polynomial.